So now that we've created the data source, I'm going to use it to create two very simple visualizations. We'll create more complex visualizations in the next module. So what I'm going to do is create a very simple clustered column chart that shows the unemployment levels for each year by state. The first thing to notice is that you will recall that in the car sales data example, Tableau listed all of the dimensions at the top and all of the measures at the bottom. Since we used relationships to create the data source in this case, Tableau keeps them on a per table basis. So I see the dimension for the 2014 economic data here, and then all of the measures associated with it at the bottom. So I'm going to simply drag name into columns and then take the unemployment level from each of those years, each of the 5 years I have data for, drag it in here. And then change it to a clustered column chart. Now, the point of doing this is that if you mouse over the various bars here for Alabama, what you see is the actual unemployment rate, right? So there's no further manipulation I have to do. These are the actual unemployment rates. And I wanted to contrast that with what happens when you have the physical view. So in this particular case, I have created physical joins between the chronic disease data set and then the 2016 economic and the 2017 economic data, as you can see by the fact that there are joins here. Now see what happens if I create a similar clustered column chart. If I now mouse over the unemployment rate, you see that it's no longer has anything to do with the actual unemployment rate in Alabama in 2016 and 2017 respectively. The reason, of course, is that in this denormalized data source, the unemployment rate is included for every line in this data source. And since by default Tableau uses sum to aggregate numeric values, I get these unrealistic numbers. I can, of course, change them by changing the measure to average. And now I get the real unemployment rate back. But if you use the logical view, as we did in the first example, I don't need to do any additional manipulation to get the correct values for my measures.